Good morning, everybody, and welcome back to my home. I want to wish everybody a happy Friday. I've done this all my 37 years of teaching every Friday. I wish people a happy Friday. It's my favorite day of the week by far, so happy Friday. This is the first of hopefully 3 videos that are coming today. This is section 1.1. Section 1.1, and it's called Functions and Notation. And for just functions, probably the single most important organizing principle in all of calculus are functions. That's why we're starting there. So a function, let's see, first off there's something called a relation between numbers, relation between numbers, and it can be anything, but we're sticking with numbers for now. And that is just if you have a number, it's got a pair. And that's it. That's in a relation. But a function is more specific. A function is a relation between numbers such that for everything in the input, there's exactly one output. Every input leads to exactly one output. A function. And again, you've been familiar with functions. You know, you've done it in algebra and everything. But here's 2 of them. It can be a machine. This is a machine. And here's one of them. We'll say this is 3x plus 1. And here's another one. We'll say this is x divided by 2. And so then we're going to take, here's a bunch of x's we're going to put into there. 0, 1, 2, -1, -2. We'll put those 3 x's in there and then get something out. So here's the f at x. Whoops, I got to move this table. This is coming soon. This is called notation. This is coming, but it's called the function's value at x. So then here, the function's value at 0 for 3x plus 1 is 3 times 0 plus 1. Function's value at 1 is 4. 2 is 7. I put a 2. 3 times 2 is 6, plus 1 is 7. The function's value at -1. Function's value at -2 is -3, here it's -2, sorry, I'm at -6 plus 1, -5. That's that function. And then this one, the function's value at 0 is 0. The function's value at 1 is a half. Function's value at 2 is 1. I'll go down. Function's value at -1 is -1/2. Function's value at -2 is -1. These are called input. These are called the output. More specifically, oh, happy Friday. More specifically, they're called domain and range. The x's, the input. Input. These are the x's. Output. These are the function's value at x, or y is the function's value at x. And we also call this the domain. And then this is the range. So if you have a function, let's draw a picture of one. Let's draw a picture of a function, and it'd be easy to see domain and range. I should have that better show. Here's a function, there's a picture of a function. It ends right here and starts right there. Domain is along the x-axis. Range, different color, is along the y-axis. Range is from here to, where does it go? Here. Range, R-A-N-G-E. Range is this way. Domain is this way. The domain are the x's. The range are essentially the y's. Oh boy, I didn't start the clock. Huh. 4 minutes. Okay. Domain and range. Oh yeah, they're also. We could also call these independent variables. Because you can put anything into it. Remember, I chose 0, 1, 2 is -1 and -2, and that's because I'm consistent always doing that. Sorry, I'm walking off camera. But they're called the independent variables. You can put anything you want into it. as long as it's in the domain. And these are called dependent variables, because it depends on the function. Whatever you put into it will go through a function and then come out, and it depends on that function. So it's called dependent variable. Function notation. This is red. I've just been using function's value at x, but notation. Please get used to this. Function's value at x. This is what y is. Y is actually the function's value at x, and we read this as the function value at x. That's some number x, and x would be a number. This, for example, is the function value at 2. The next 4 courses you're going to be taking this one and Calc 1, 2, and 3. Please get used to abbreviations. You're going to write functions a lot of time. FN, apostrophe S. You know, that's what I do. So we evaluate a function. Let's say I got a couple of them here. To evaluate a function, evaluate a function. Okay, we'll call the function, let me see, x squared minus 3, plus 3x minus 4. Plus 3x minus 4. This is a function, and this is the rule to what you're going to do for x, and let's go f that. I think I had 6. Oh no, 6 is the answer. Oh, let's find f at 2. F at 2 would be 2 squared plus 3 times 2 minus 4, and I think there's a 6. 4 plus 6 is 10, minus 4 is 6. The function's value at 2 is 6. That's how you say that. The function's value at 2 is 6. Lots of homework problems on this. Okay, so now we can solve a function. Solving. Where's that chalk? I need a better piece of chalk. Solving function. This one? I think. Oh, okay. Well, no, let's keep it simple. Solve f at x equals 2x minus 1 for f at x well, f at 2 is 4 minus 1. Whoops. F at 2 is 4 minus 1, which is 3. But then, like, what is, say, 7? What value is 7? So we're actually going to solve this. So you have to go 2x minus 1 is 7. So 2x is 8. X is 4. So the function value at 4 is what we're looking for. 7. That's solving a function. You just set it equal. We do lots of this throughout this course. Pretty much getting there. We're at 8 minutes right now. I'll be under 10, I hope. Just a couple of things. Page 19 in your text. I asked you to do all of page 19 in your text. It's called the vertical line test. And I say do all of page 19 because you should glance at it and say, oh, yes, yes, no, yes, yes, no, yes, no, yes. Whatever it is, I don't know. Meaning that if you have a picture of a function, that's a function because every single value here leads to a value over here. That's not a function because this value right here for x leads to not only this one, f at x, but this one as well. So you say, well, f at, say that's 1, I don't know. So the value at f at 1 is here and here, but that's not a function. It can't be because for every input there's only one output. So here's a vertical line test. If you can draw a vertical line and hit the thing more than once, here I hit it here, here I hit it there, it's not a function. Not a function. Function. Vertical line test. All of page 19. I hope you can just look at it and say yes, no, yes, no, yes, no, yeah, whatever it is. And then there's one more thing. This is on page, sorry. This is on page, come on, Brad. 15, 17. 16 and 17. and they're called toolkit functions. And the last thing I ask you to do on your homework is draw a real quick sketch of all the toolkit functions. And so there's a constant function, there is a identity function, a quadratic. I should look at my list. Well, anyway, so each one of these, a constant function is just a vertical, horizontal line. A identity function is the 45-degree angle through the, this is y equals x, by the way. This is y equals c, or f of x, sorry about that. And this is f of x equals x. It's just a vertical line. Quadratic function is squared, and it looks like this. By the way, if this was x to the fourth, x to the sixth, etc., it would look the same, except it would be squozen in a little further. Well, let's go in order. Cubic function, so I'm getting so low, is f of x equals x cubed, and that looks like this. Cubic, y is f of x equals x cubed, and a few more, and then we're finished. This is going a little longer than I had hoped. Cubic, let me write them all. Reciprocal, square root, cube root. Reciprocal squared. Square root, cube root. These are called your toolkit functions. Because if you remember these, if you can just remember these off the top of your head, it would be very helpful when we get to graphing. So a reciprocal function is f of x 1 over x. It looks like this. It's got two branches, one here and one here. They're asymptotic. I always use this function to explain what an asymptote is. Reciprocal squared will look like this. This one is going up. Is the only thing. Oh, by the way, it's 1 over x squared. Square root function looks like this. 0 is part of the domain. And a cube root function looks like this. Hope you can see that. Those are just nice to have in your toolkit. And the very last problem on the homework, I said just draw them and really take no longer than 8 minutes to draw them. 12 minutes, almost 13 minutes long. This is lesson number 1. See you soon. I'm going to do 2 and 3 today.